Hi, everybody. I'm Marcus. I'm Senior Developer Relations at Edge and Node, one of the core development teams working on building the graph. And I'm really excited to be here today to unveil in developer preview mode AMP, which is our version of a database specific for the blockchain. So we'll go into what that means, and we'll go into actually the code today. This is the first time the world is actually seeing the code in its full glory. So we are at the hackathon. If anyone here is hacking at ETH Global, we're offering 6K total in prizes, and it's best use of AMP data sets. I'm going to go into what a data set is in a little bit. And if you are interested in the hackathon, feel free to scan. I could step out of the way. There's a few other prizes we also have for the ETH Global Hackathon. Best use of the graph for AI use cases and best use of subgraph advanced features. If anybody has built with subgraphs in the past, they are much better now. And there's many more features such as MCP servers. We have token API. We have AI use cases. Lots of different ways to use the graph today. So if anyone here wants to look specifically at AMP and build with this new database, this is the repository. Literally just went public less than 2 hours ago. Brand new code. It's been worked on for 2 years, so we're really happy to unveil this today. So let's back up and try to understand AMP from the ground up and why we need AMP today. If anyone here has worked with Postgres, yeah? Okay, it works. There's lots of different ways to plug in to Postgres. It's an incredibly flexible, dynamic ecosystem. However, it was not designed for blockchain in mind. And with the world we are in today, it would be nice if we were to have a blockchain native database. So we decided to start from a clean slate and imagine what a database could be from the ground up if it knew it was going to connect to the blockchain from day one, and that is AMP. So it is a blockchain native database, and today we're releasing it in developer preview mode in an open source format. So feel free to dive into the code. We are happy to release it as such. It has some features. We're going to go through these relatively quickly because I do want to get to the code. It is local first. If anyone here has developed on blockchain before, sometimes it's local, sometimes it's not. And we really wanted to go to local first as much as possible. There's local environments all the time. You're able to query blockchain data with SQL. You want to I imagine this not as you are going to an RPC or you're going to some type of indexing or some type of streaming. It does have that, but you want to imagine this as a database. We're designing this to be ergonomic like a database, and SQL is a big part of that. You can do streaming or you can do batch queries, and there's transformations at either time. And that really unlocks a lot of flexibility. If you want to have your database have storage that has undergone transformations, that's huge. Or if you just want to do those transformations at query time, it's very flexible depending on your data needs. It has automatic reorg handling. If anyone here has gone through a chain reorg, that's not fun. AMP handles that for you. It is multi-chain. It is multi-contract. Another thing I need to put in here, there's verified data. So you're able to actually send a query and know that when you're getting that data back, it's verified by being on chain. Small caveat, it is verified on raw data, not on transformed data. We are working on that right now. Also, if anyone has built with subgraphs before, subgraphs are on the graph network. So that is the path for AMP to go decentralized. If you want to take AMP data and plug it into a subgraph, you can do that and then put it onto the graph network and decentralize your databases. So performant and scalable. A lot of this building with AMP began 2 to 3 years ago with understanding from institutions. Institutions were reaching out and saying they needed subgraphs to be more flexible, graph node to be more, let's just say that, graph node to be more, and graph node and subgraphs are amazing. However, it needed to have a slight different flavor, and that's where AMP is coming, where it has different connections and different abilities that are more attuned to both legacy code that has been around with institutions for decades, as well as the next decade of crypto, and has that flexibility to handle both cases. Some performance. Latency at chain head around 100 milliseconds. So it's very, very close to chain head at all times. Events decoded per second, 4 million events per second. And this is a good one. Querying all block hashes since Genesis block on Ethereum, 5 seconds. So it's very fast and incredibly performant. We also have metrics on how backfills occur. We have metrics on comparing directly to competitors. I'm not going to get into this right now. We're just staying with metrics. here today. One is to do compute on transactions, not just filling it into our database, but to actually run compute 35 seconds. All transactions since Genesis to do compute, and we found that adding more compute was not necessarily slowing it down very much at all. If it touches AMP, it's fast, and that's what I want developers to take away from this as much as possible. So with that being said, I think I'm doing around 8 minutes right there. That's about 8 minutes? 7 minutes. Okay, cool. Plenty of time. This is my first time giving the talk in real time, so I'm like timing it for the 20 minutes here. Let's build some key parts of this that are to be understood specifically for the hackathon, and also just getting started with this whole thing, is being able to interact with a database. I want you to think about this. Typically, when you want to go get data, either through an RPC or through subgraphs or through substreams or any of our competitors' products, you're not using SQL. And this is an opportunity to go back to your old computer science days and think filtering. It's already in the database. It's already there. It's already stored. All you have to do is filter. And so that's a big thing. These databases that we're building are raw blockchain data that expose the ability to transform that data to whatever your use case is. So that's a big takeaway. I want you to think about this. How would you use SQL to get raw blockchain data to transform it to whatever the heck you want to build? Very, very flexible. In terms of that flexibility and power, we package UDFs as part of the AMP repository, where you can run more complex transformations, encoding, decoding, and such, not only in SQL. That can be in TypeScript, and there's other libraries that we're looking at supporting, but if you like to use TypeScript to do complex transformations that SQL would be too cumbersome, we support that today. So it's very ergonomic, as ergonomic as we can make it right now in developer preview mode. So those are the two topics I want to go over before you go into it. Now we're going to get into how to win money at this hackathon, and also just conceptually how we are organizing data to be scalable, portable, to really have the ability to truly be a database. And that is data sets. We call them data sets. They are portable databases. That's a good way of thinking about it. They could be local. They could be hosted by Edge and Node, which we do host data sets for you just to hit the endpoint and have all that raw data to your needs. You could have it on-prem. You could do it horizontally scaled on multiple computers. It's a database. So we want to have people think of it like that, and those are data sets. Really, there's raw tables, which are as a database, and then you have the derived tables. Derived has gone through transformations for specific use cases. Knowing all that, let's get into it. So let's go into the code, and let's start right now with the most important file in building right now, and that is defining our data sets. Essentially saying, hey, if we're going to start building, we need to know what we're building on. And this is all local right now. And just like I said, it is local development environment supported. Let's go ahead and say, hey, we've got this local data set that we're generating. What's it doing? And we have a little starter kit template that shows you exactly what it's doing in real time. Right now, we're just simply saying we want to name a data set. We're going to name it a counter data set. And it's going to be taking data from the ABI and also an RPC and going to create tables from it. It's very, very minimal code, single lines. That's what we want. Let's go ahead and see what that looks like in the code itself running. So all you have to do is run just dev, and there we go. We are running it, and AMP is already running. I wanted to get it. I couldn't trust the Wi-Fi. I didn't want to pull things in, so it's just running right now. And we can see in the logs, it's checking on Anvil, which is our local instance. Remember, it has local development. It's really optimized. And let's go ahead and play with the front end to see what our AMP is doing in the code. So all it is doing for now, just for demonstration purposes, is, let's make this a little bigger. There we go. And infra AMP. We already have our data in its raw tables as blocks, logs, and transactions. You're free to do transformations on that, in which we've already done one transformation, and we've created a decremented and incremented. Basically, we've seen when that smart contract has been interacted with, and then from there, we're populating that raw data into a transformation, and then it settles in this table. All right, so if we just click here, we can see in real time, this data is being put into our database, streaming directly in. All right, so it's dropping right in from the front end, very efficient. Now, the next thing is saying, cool, we've got this data in here. That's very nice. We can actually run a query on it, not print. We want README. And we can run our SQL queries directly on these data sets. Here we are. Query from the CLI. I'm not going to run that because the screen is too small, but you could just simply run SQL directly against that database. Well, we got time, don't we? Yeah, well, let's keep on going. We could run directly in our terminal. Make it bigger. There it is. We could run SQL directly from our terminal, and we get data back just like any database. All right, so we could use SQL to interact with that. That's really, really nice. Now, what if we want to build more transformations on top of that? Let's say we want to take some raw data here, some raw data there, do filtering on that data. We would do logical operators. We want to run UDFs. That's very easy with AMP. All you have to do is simply look in this section right here where we're generating tables and say, well, let's go ahead and generate some more tables to our spec. And so what I'm going to do is grab the README. We have example code all throughout this README, so feel free to grab it. And with this, we are going to simply drop this code in. And I want you to have guys take a look at the incremented, decremented tables. Those are created by the default template. All to do, this is basically hot reloading. If I just press save, we have a new table saved in our database just by putting this SQL in here. So it's using SQL not only to at query time to actually get that data back, but actually to define the tables themselves. What we like about SQL is it's declarative, and agents love declarative languages. And being able to interact with this database is very easy for agents as opposed to using GraphQL. We have been using GraphQL for years, just had limitations. It wasn't as declarative, well, it wasn't declarative. And from here, we have a much more declarative language that's able to be much more approachable for agents to consume data. So right now, we've essentially brought this raw data in here, and we've defined where it's coming from in the raw data set. We're just getting raw, and we're filtering. And it's simply going to pass it into a new active blocks table. Let's say we want to do any compute. Let's say we want to do different joins. Let's say we have multi-chain. Let's say we have 4 or 5 different chains here with 6 or 7 different smart contracts. We can actually bring in from a single query 4 or 5 different chains and also filter by specific smart contracts, because once again, we're interacting with a database. So you just filter by smart contract, and all you have to do is dump in a different provider. This is using anvil.toml, but it's as easy as using a different RPC endpoint to then begin ingesting either locally or to our hosted databases or hosted data sets. And then from there, you can create incredibly powerful SQL queries from and returns from just one query, across chain, across smart contract, joins, transformations, it's all there. So before I keep on going, you seem interested. So if there's any questions, I've got time here. Any questions on that? Yes.
To what extent is this used in production, and like how does it deal with the size of like production databases and or blockchains? Is that all battle tested?
Oh, great question. The code was just public 2 hours ago. So we are in open source developer preview mode right now, and it is not battle tested. We're in developer preview mode. We've been working on this for 2 years. And we will let you know when it is battle tested. This is the part of the battle testing, to get in front of developers like yourself. So yeah, good question. Yeah. Yes. Oh yeah. So I'll go back to some metrics here that we're very proud of. So latency at chain head is about 100 milliseconds. Come on. 4 million events per second. I think that was it. Yep. Events decoded per second. And querying all block hashes since Genesis for Ethereum, 5 seconds. So yes, we're very happy with that. And then running transformations or compute, excuse me, this would be, yes, compute on this. All transactions since Genesis, instead of 5 seconds, 35 seconds. So we're doing very well with that. There's other stats we have if you're interested in terms of how the data is being populated, backfills. We have a lot of metrics if you're more interested, and I get your Telegram, and then we can share if you're more interested in that. No, this is coming from chain. This is coming from an RPC. And so we RPC or Firehose, we connect to one or the other. Just depends. I believe this was connected to a Firehose.
So this would largely, it depends a lot on the network
It
connection.
also depends on Wi-Fi we were finding and like internet connection. Like we're literally getting bottlenecked by the internet. So it's like, yeah. So, cool. Yeah, it's fun. It's fun. Like to see the metrics coming in, the whole team was like, what the fuck? Like really, really exciting. So, okay. So, adding a new provider. This is Anvil because local development is really emphasized here. Oh, you asked about scaling. Horizontal scaling is baked in. So we start local. You could have these on multiple computers. We have a hosted data sets. We already are hosting many data sets where you, instead of working locally or going to, let's say, an RPC like you could traditionally, we're essentially taking the databases and saying you can just hit our endpoint. And so that's there. Let's go ahead and look at other different tooling that can help the development experience. And that would be just Studio. And this is really for improving the ability to test queries through a UI. You can see the actual data set tables that are there. You can see the events, you can see sources, and also get a preview of some UDFs. And just play around and see what works locally. We really want it to be more ergonomic than, we're looking at like a Foundry and Hard Hat kind of experience where it's just local as much as possible. And from there, we try to make every single process that was reasonable be horizontally scaled. And so you're able to run it on multiple computers and throw as much processing as you want it. You can own the entire pipeline, or you can have it be as flexible as having us take ownership of the data and whatever suits your needs. So that's the local studio. We're really happy with that. And from there, we also have the playground, which is the way to explore already published data sets that are being hosted by us. And so you're going to the internet now, that's not local anymore, and you can compare these. This is basically raw data or potentially transformed data, just depending on if someone wants to publish a data set with some interesting transformations. You can say, oh, thank you, that's very interesting, and you're already at the chain head. We'll just go ahead and send some queries directly to that. So this is already being built on. You could build locally, have a good time, get your data organized exactly how you want it on an Anvil instance or a Hard Hat instance. And then from there say, ooh, that's interesting. Let's plug it in to actual data on chain and get it to work. And the database will fill on our data sets. And from there, you get to work without having to manage the infrastructure on your own. Sorry? Yes, absolutely. Yeah. Let's go ahead and dive into Lido v3 Ethereum. I'm just picking one right here. And it's just SQL. So you could, this is had SQL had done transformations in streaming. And so it's settling the data. Hopefully the Wi-Fi works, but you can never guarantee. It will always have the raw data too. So you could run the query, you could do transformations at query time if you'd like as well. It'll take a little bit longer. And if you're in, I was talking with some data analysts and I was like, how much time are you comfortable with waiting for, like, you're just trying to get crazy amounts of data? And they're like, a few minutes. I was like, we're totally on point with that. If you're an app developer, you're going to want to do derived data sets and have that be near real time as much as possible. Both are possible with what we're building. Well, unfortunately, the internet's not working because it's not our data sets aren't working. This is connected to ENS, and ENS is not even working. So we're going to just, I'll get you links and you can go play around with it. So that's about 20 minutes right there. Let's go back to the slides. And there we go. We talked about that. We talked about the playground. And I don't even know if that's going to go full screen, but we're just going to do this. Hard problems, bold goals, get involved. We're hiring. Please talk to us. If you like data, jump in. It's a good time. And we're building in the open. All of this is open source. All of it is open source. So we're doing, I'm not a licensed guy. I don't know a heck of a lot about it, but BUSL, that's what we're doing. So I think it gives us a 3-year window. I think 2 year. I'm learning in real time. But essentially it's open source. Anyone can actually take a look at it and continue building with it in some type of model. So you guys might know more than me in terms of the open source world. So, sorry, is it BSL? Yeah, BSL, yes. It's not the best. But we're that was what was decided from our team. So yes, exactly. So anyways, that is AMP. So.